Okay, in section 1.4, we're going to kind of shift gears a little bit, and now we're going to look at graphing lines. So we are going to use a lot of the tools we've already gone over with simplifying expressions and stuff like that, but we're going to go ahead and translate it into graphing. So we're going to start with linear functions, our equations with two variables. Typically, we like to use x and y. Sometimes you can use other variables, but that's what we're going to see most of. These equations have infinitely many solutions. So on the previous section, we had problems like this. I'm just going to put a very easy one. So like x plus 2 equals 5, right? And so the answer was 3, and that's it. X was 3, right? Well, if you look at our example right here, if you have x plus y equals 5, there's infinitely many ways that you could come up with combinations that add up to 5. So what we'll do is we'll go ahead and list some of those combinations. And so what we'll do is we're actually going to make a table, and we should probably be pretty familiar with tables. So I'm just going to make like this little T right here. And so I'm going to put X right here, and I'm going to put Y right here. And so we'll go ahead and pick some values of combinations that add to 5. So something easy would be like 1 and 4, right? 1 plus 4 is 5. I could do 4 and 1, right? 4 plus 1 is 5. Or if I want to get a little more creative, I could do something like negative 2 and 7. If you add those together, that does add up to 5 also. Let's see, I could do 5 and 0. Okay, so I could, once again, it's infinite. I could just come up with pairs all day and never stop. So now we're going to go ahead and put these points on our graph. So this is our x-axis, this is our y-axis, and so x is going to tell us how we move left and right from the origin, which is right here. That's where we're going to start, is right there in the middle. And then y is going to tell us how we move up and down. So we have 1, 4, so it's positive 1, so I'm going to go to the right 1, and then positive 4, so I go up 4 right there. And then my next one is 4, 1, so I'm going to go over 4 and then up 1 right there. Now I have x is negative 2, so that means I'm going to have to go backwards to over here, and then my y value is 7, which is slightly off my graph. I'll just go ahead and put it up there. And then let's see, my last point I picked out was, let's see, 5, 0. So I'm going to go over 5, and then I don't go up at all. It's just, that's where the y value is 0, is right there. Okay, so the origin right there starts at 0, 0, and then we just kind of move as this tells us to find those ordered pairs. And so what we should notice is they do all line up in a row. Okay, and so if they don't line up in a row, then you kind of know that something is wrong in your table. So really, it only requires 2 points to draw a line. So when you're doing your homework and you're graphing these on your homework, it's not that hard. You'll use the line tool, and you only need 2 points to go ahead, and then the line will show up on your graph right there. Okay, so that's one way of doing it. We just kind of, this is a pretty simple one. X plus y equals 5. They're not always going to be that easy. So how do I find these solutions, these points to my equation? Well, and one other thing before I move on, just to make sure we understand, this line represents all the ordered pairs that satisfy that equation right there. So if I pick out any point, decimals, fractions, whatever, if I pick out any points on this line and it continues, up this direction and that direction, if I pick any point on that line and plug it in, it will come out as a true statement right there. Okay, so let's see. How do I find x and y intercepts of linear equations? So that's another good way to find 2 points. So those are probably the two easiest points to find of a line. Okay, so our x and y intercepts, by definition, to find the x-intercept, you let y equal 0. So you can see the x-intercept right here. So as long as y is 0, you have no place, you're not going to go up or down, so you're going to land on the x-axis. Same thing with the y-intercept, except this time you let x equal 0. So if x equals 0, you're not going to move left or right when you start from the origin. So the only place you have to go is up or down or whatever, and you're going to land on the y-axis. And so those are some key points that we're going to use throughout the semester, not just with lines, but with other functions that we'll graph as we move forward. And the definition does not change. So if you want to find an x-intercept, you let y equal 0. If you want to find an x-intercept, I'm sorry, a y-intercept, you let x equals 0, x-intercept, you let y equal 0. So let's go ahead and use those definitions here. So find the intercepts of the line, and then we're going to go ahead and graph it. So if I want to find the x-intercept, by definition, what we'll do is let y equal 0. So here's my x-axis, here's my y-axis. So if y is 0, that means I'm only going to shift left or right to wherever that point's going to be. So we're going to go ahead and let y equal 0. So we're left with x minus 2 equals 0. Then we'll go ahead and add 2 to both sides. So we get x equals 2. So we're going to go ahead and write these as ordered pairs. The way we write ordered pairs is x goes first and then y, and we put it in parentheses. That's what indicates that we're talking about an ordered pair. So I'm going to go ahead and write this as 2 comma 0. And so that point is right here. So you start the origin, the x tells you to move positive 2, so we go to the right, and then my y value is 0, so I stay right there, and that's my x-intercept. Now for the y-intercept, this time we're going to let x equal 0. Okay, so we're going to have 0 minus 2 equals y, and then 0 take away 2 is just negative 2. So our y value is negative 2 when x equals 0. So once again, as an ordered pair, we'd write that as 0 comma negative 2, and those parentheses indicate the ordered pair. So 0 and then negative 2, so I'm going to have to go down 2, and there's my y-intercept. And then we'll go ahead and graph that line right there. So let's see, about like that. And there we go. So I've got a couple more of these for us to try, where the equation will look a little different in each example, but basically the fundamentals don't change. If you want to find x-intercept, let y equal 0, y-intercept, we're going to let x equal 0 in that case. Okay, so here we go. So we'll start with our x-intercept on this one. So we're going to let y equal 0. So let's see, we're left with 2 times x plus, this will become 3 times 0, because I'm going to let y equal 0 equals 6. And then from here, it should be pretty simple algebra. So this will become 2x plus 0 equals 6. And that plus 0 is really not necessary, because plus 0 it doesn't change anything. So it's really just going to be 2x equals 6. Then we'll divide both sides by 2, and we get x equals 3. So our ordered pair here will be 3 comma 0. So over 3, there we go. It's our x-intercept. So then our y-intercept, we'll let x equal 0 this time. So 2 times 0 plus 3 times y equals 6. This right here, it's going to turn into 0. If you want to, you can just cross it out. And I could have done that on the previous one, but I just kind of wanted to show all my steps at first. So now I'm left with 3y equals 6. And so we'll go ahead and divide both sides by 3. And we're left with y equals 2. So my ordered pair is at 0, 2. So 0 and then up 2, so I land right there. And now we'll go ahead and draw a line through those 2 points. So once again, just kind of hit on this, what we're graphing is all the solutions to that equation. So if I were to pick out any point on this line and plug in the x and y value, it would equal 6 once I do the algebra. Any of these points down here, way up here, any of these points that are on that line are the solutions to that equation. All right. Let's see, I think I got two more for us here. So let's see, we'll start with our x-intercept again. So I'm going to let y equal 0. So 5 times 0 equals negative 15 plus 3x. So 0 times anything, 0. And then now it's time to solve this. So there's a couple of different things you could do here. You could add 15 to both sides, or you could subtract 3x from both sides. I'm going to go ahead and add 15 to both sides, but you could do it either way. So let's see, that cancels out. 15 equals 3x. And we'll go ahead and divide by 3. So 5 equals x, or x equals 5. So that ordered pair is at 5, 0. So right there. Okay. Now let's find our y-intercept. We'll let x equal 0. So let's see, 5y equals negative 15 plus 3 times 0. So once again, I can just cross that out because 3 times 0 is 0. So I'm really just left with this equation here. So I'm going to go ahead and divide both sides by 5. And so we'll get y equals negative 3. And so that ordered pair is at 0, negative 3. Right there. And then we'll go ahead and graph that line. So let's see. There we go. All right. Let's look at this one here. So we'll start with our x-intercept. So let's see, 2x minus 3 times 0 equals 6. So right there, that's going to turn into 0. And then if you're subtracting 0, that's not going to change the 2x. 2x take away 0 is still 2x equals 6. Then we divide by 2, and we get x equals 3. So that ordered pair is at 3, 0. And now we'll go ahead and find our y-intercept. Let x equal 0. So let's see, 2 times 0 minus 3y equals 6. So this turns into 0. Okay, so 0 take away 3y. So this will be a negative 3y. So be careful. Make sure you still have the minus basically turns into a negative right there. Equals negative 6. And then we'll divide both sides by negative 3. And so positive 6 divided by negative 3 will become a negative 2. And so our ordered pair here is 0, negative 2. Right there. And let's see, we'll go ahead and connect that. And there we go. Okay, and so that's going to do it for part 1. So there are going to be more parts to this section. So we just kind of started looking at lines and how to graph them. And so we're going to investigate more the attributes of lines in the next part.